Hi, my name is Darren Dougherty, and this project is a quick statistical examination of diamonds and their prices using a built-in R dataset called diamonds. So, question, are diamonds valuable? Well, yeah, but what qualities of a diamond make it more valuable than others? That is what we will be comparing with a couple simple linear regressions. Let's talk data. The diamonds dataset is built into ggplot2. So if you have ggplot2 loaded or the tidyverse, you have this dataset. We look at 53,940 individual diamonds and how they measure against these attributes. Here, I will be focusing on carat, color, and price. In diamondology, carat refers to the mass, and 1 carat is equal to 200 milligrams. Color and price should be pretty self-explanatory. Here, we have a sample of the diamonds dataset. The first thing I did is I ran a linear model on the relationship between price and carat. This is a simple linear regression because it only compares the relationship between two factors, price and carat. If I asked you, is a larger diamond more valuable than a smaller diamond? You would probably reply, duh, obviously, but even though that seems pretty intuitive, the higher the carat, the more valuable a diamond is. How do we prove it statistically? Let's make this a bit bigger and take a closer look. So this is a lot of text, but let me walk you through what I commanded R to do. I told R, use the data frame I created for diamonds. This is the data I want you to use. Create a linear model. That's what the LM function stands for. And I want you to take price and explain it by carat. Then give me a summary. There are really only two things that we need to look at. My question when I ran this linear model was, can the price of a diamond be explained by its carat? And yeah, anyone knows that a bigger diamond is worth more money. But here we have statistically proven it. And I can show you by looking at two things, the p-value and the multiple R squared. First is our p-value. Simply put, smaller the p-value, the more certain that we can be that a relationship does exist between price and carat. 2.2 e to the negative 16 is an extremely small number, so we are very certain that a relationship between the two does exist. The second thing is our multiple R squared. This number will be between 0 and 1 and shows how strongly the explanatory value, in this case carat, affects our price. Our value here is 0.8493, or just about 85%. So in very simple terms, when I'm looking at a diamond and wondering how valuable it is, the carat is going to be a huge factor in that decision. All right, let's take the same methodology and apply it to another pair of variables. Okay, here we have pretty much the same process as our last model, but we are instead saying, hey R, show me how price is explained by color. Our p-value is less than 2.2 e to the negative 16. Remember that a small number here means we can be confident that a relationship does exist between price and color, and this is indeed a very small number. When we look at our multiple R squared value, we see it is much lower than the same value comparing carat and price from the last model. And remember that this value is between 0 and 1 and compares how strongly color will influence price. The value for carat and price was about 85%, whereas our value here of 0.03128 is only about 3%. That is not a lot. When we look at our p-value and multiple R squared for the color price dynamic, we can infer that there almost certainly is a relationship between color and price. Of that we can be very sure, but that relationship has a pretty weak effect. In summary, carat very likely influences diamond price, and that influence is very strong. Color also very likely influences diamond price, but that influence is not very strong. Thank you for taking the time to watch my presentation. I can be reached by email with Darren@darren.pro or at LinkedIn, where my URL is just my first and last name. That being said, thanks again for watching.